So we're going to go to the next question that was sent to us via social media. Let's go and check out what this question is all about. Right. So it says to us here, right, we need to prove without the use of a calculator that if the sine of 28 degrees is A and the cosine of 32 degrees is B, then B multiplied by the square root of 1 minus A squared minus A multiplied by the square root of 1 minus B squared is as good as half. Okay, cool. So this question is actually very, very nice. Let's look at it. I don't know about you guys, but there's a lot of the things that you guys get in grade 12 that come directly from previous grades, right? There's some skills which I call basic skills that you need to have. For example, your ability to substitute comes natural to you. We shouldn't even be discussing substitution with you. When you have something given to you and there are variables appearing in your question, it makes common sense for you to take that information and substitute and see what is going to happen. Because most of you would stare at a question. Don't stare at a question. Look at it and think about what you can do. So in this context, I'm going to simply take those variables that I have, the values of the variables, and substitute in this and check where is this taking me. Hopefully I'll be able to see where this is going, and then maybe after the math then comes in. Substitution, solving equations, linear, quadratic, exponential, whatever it might be, those basics, we expect you to have them. Even simultaneous is a popular skill that we want you to always have. So in this case, I see that I need to substitute. I don't know where this is going. I'm just noticing that I need to substitute. We'll see as we proceed with this. All right, cool. So what I'm going to do is I'm going to say, okay, fine. On the left-hand side, I have here in my question B and the square root of whatever is going on there. So I'm going to start my proof because we need to prove. Every time we need to do proof questions, always start them by taking one side and trying to simplify it until it looks like the other side. So the left-hand side was given to us by B multiplied by the square root of 1 minus A squared. This is what we're having, minus A multiplied by the square root of 1 minus B squared. This is what is on the left hand side. And we need to show that this is actually as good as half. Right. So what is B? According to the info that we were given, B is basically the cosine of 32 degrees. So I'm going to write that this is cos of 32 degrees multiplied by the square root of 1 minus your A. What is A? A is sine 28, but it's squared. So I'm going to write sine squared of 28 degrees. And then that's actually what I have there. Minus A. I'm going back to A now. A was given to us as the sine of 28 degrees. And we're multiplying this with the square root of 1 minus B. And our B is cos, and it's also squared. So that's cos squared 32 degrees. Very important. I hope you guys can see what is going on there. All right. Now, we're now going to try and simplify this. What do you notice when you look at this? Well, I see something very exciting, which is based on what we call the squares identity from grade 11. What do we know about the squares identity? Well, in this part here, I was told in grade 11 that the sine squared of any angle plus the cosine squared of the same angle is as good as 1. So this is from the squares identity of grade 11. So I'm going to take that result and use it to try and simplify this, right? So if you look there, you will notice that I'm going to keep this cosine of 32 degrees and multiply it by the square root of. But look at this, 1 minus sine squared is as good as cos squared. And this comes from the squares identity, cos squared 28 degrees. Minus, then there's sine 28 degrees, which I'm writing. Okay, multiplied by, again, this one of 1 minus cos squared, that's the square root of basically sine squared 32 degrees. That's actually what we're getting here. Right. Now, you'll agree with me that the square root helps you to remove a square in any expression. So this is as good as the cosine of 32 degrees multiplied by the cosine of 28 degrees, because the square and the square root deal with each other. It's very, very evident that this and that will cancel out. Similarly, this side, that and that will simply cancel out. Then you'll have minus the sine of 28 degrees multiplied by the sine of 32 degrees. And when you look at this, now I'm looking at something here that looks very terrible. I don't know what is going on. It's not special angles. If it was special angles, we know the values of special angles without the use of a calculator, right? But now in this context, the only thing that I'm going to think about, which is what I told you earlier on, if you can identify your compound and double angles as a matriculant, you can see now, no man, this thing looks like something I've seen before. And if you go to the information sheet, anything that says cos and sine is definitely the expansion of cosine. So let's see what is going on here. Cos 32, cos 28, this is expansion of cos because it's cos, sine. So this is simply the cosine of some angle, and if it's a minus there, the sign changes to a plus. So I'm looking for what must come here and what must come here, because what we are looking at there is simply straightforward from the expansion of cos. So my first angle is 32 degrees and my second angle is 28 degrees. And when you sum up 32 and 28, you're simply going to get 60 degrees. So this is the cosine of 60 degrees. And we know from our knowledge of special angles that the cosine of 60 degrees is as good as 1/2. And then we have succeeded to prove that the left-hand side is indeed equal to the right-hand side, because the right-hand side was simply equal to half, right? So I hope you can see what you guys had to do. In this case, it's just a matter of substitution. After substituting, the math guides you. It tells you what to do next. You just keep following and following. When you identify compound angles and you identify double angles, then reverse back to them, right? It's important for you to know when you have something, how do you expand it? And when you have an expanded version of the double angle, how do you compress it back? So you can only be able to see this if you can identify it in a question. That's why it's important for you to familiarize yourself with what is going on there.